Hello student, welcome to my channel The Learn Physics. Today I will be discussing sound wave, that is cause of production of sound, propagation of sound wave from one point to another point, the medium for propagation of sound wave, definition of some important term like amplitude of vibration, time period, wavelength, frequency and velocity of sound wave, then reflection of sound wave, echo and use of sonar, and finally characteristics of sound wave. So this video will be extremely beneficial for you. Please like, comment and share the video. Okay, now let's start. Now first of all, sound. Right. Sound is an energy which propagates through a medium from one point to another point without any physical transport of the medium. Now cause of production of sound wave. Look at this. Suppose this is a tuning fork. It is a fixed here. A table tennis ball is suspended by means of a string and touched with it. Now the prong of the tuning fork is strike. So it starts vibrating and sound produced. During its vibration, the prongs are moving along this direction, here this direction and this direction. Now the table tennis ball oscillates between this point and this point. The sound is only produced when vibration of tuning fork are occur. So vibration is the cause of production of sound wave. Now when tuning fork are vibrating, its prong moves closer to each other and moves away from each other. In each vibration, the prong moving this direction, then this, then this, then this. So during outward motion of the prong, the air medium get compressed, produces compression. Okay, this is the compression. When prong moves away from this position, when the prong moves from this position to this position, the air medium get rarefied, produces, this is the rarefaction. Okay, due to vibration of the fork in this way, the compression and rarefaction are produced in the media. By producing compression and rarefaction, the sound wave propagates from one point to another point. So now the length of a compression and a rarefaction gives the wavelength of the wave. Okay? And time required for complete compression and rarefaction is called period. And number of compression and rarefaction produced in 1 second is called frequency of oscillation or frequency of vibration. Okay? Now look at this. In this case, the wave propagates along this direction and particle of the medium vibrates along this direction. So the vibration of the particle is parallel to the direction of propagation. This types of wave is called longitudinal wave. In longitudinal wave, the total length of compression and rarefaction is called wavelength. And longitudinal wave propagates through solid, liquid and gaseous medium. Okay? As sound wave is a mechanical wave, so a mechanical medium is required for the propagation of sound wave. Now this experiment proves that a mechanical medium is required for the propagation of sound wave. Now look at this. This is a glass jar. This is a electric bell and this is the gong. A electric connection is made with the electric bell with a switch, and a vacuum pump is arranged here. Switch is on here. So sound is produced by electric bell. Now the air inside the jar is slowly evacuated. Now the intensity of sound of the bell gets decreased. When whole air in the jar is evacuated, no sound is heard. Still the bell is ringing. But this cannot be heard as there is no air medium here. Again air is introduced in the jar, the sound of the bell is heard. From this experiment it proves that a mechanical medium is required for the propagation of sound wave. Okay? If an explosion takes place on moon or on sun, a sound of explosion is not heard from the earth's surface, as most of the space between earth and moon and earth and sun are vacuum. Now a question to you: if an astronaut clap his hand, will he or she hear the sound? Give answer in the comment. Okay? Now important term related to sound wave is amplitude of vibration. Look at this. This is the vibrating particle. It oscillates from this position to this position. The maximum displacement from mean position is called amplitude. Now wavelength. The wave travels in a complete oscillation is called wavelength. Look at this. In a complete oscillation, wave produces a compression and a rarefaction. So sum of length of a compression, now sum of length of a compression region and a rarefaction region is called wavelength. Now the distance between two consecutive midpoint of compression is also called wavelength. Now time period of a wave. The time required for one complete oscillation is called time period. So in a time period, a wave produces a compression and a rarefaction. Okay? Now frequency. The number of oscillations per second is called frequency. Look at this, the relation between frequency and nu. Look at this, in time t, look at this, in time t, number of oscillation is 1. Now in unit time, the number of oscillation is 1 by t. In unit time, number of oscillation is the frequency. So here, look at this, frequency equal to 1 by t. Okay? Now wave velocity. The distance traveled by an wave in 1 second is called wave velocity. Now look at this, in time t, the wave travels the distance lambda. Now in 1 second, the wave travels lambda by t. So this is the v, is the lambda by t. Now look at this, 1 by t equal to nu. So here, this is the nu lambda, is the speed of wave. Okay? Understood? Next. The frequency of wave is 220 Hz and velocity of the wave is 440 meter per second. We have to calculate the wavelength of the wave. Now, the relation between v, nu and lambda is v equal to, this is the nu lambda. So here lambda is equal to, look at this is the v by nu. Here v is equal to 440 meter per second and this is the 220 Hertz. So look at this is the 440 divided by this is the 220. So this cancel out. Therefore this is the 2 meter. Therefore wavelength of the wave is 2 meter. Okay, next. The frequency of a wave is 550 Hertz. We have to calculate the time interval between two successive compression. That means the time period of oscillation. Look at this, here nu is given and we have to calculate t. Now time period t equal to, this is the 1 by nu. So this is the 1 by 550. So time period t is the 1 by nu and nu equal to 1 by 550. So look at this is the 1000 into 10 to the power minus 3 by 550. Okay, look at this is the 20 by 11 into 10 to the power minus 3 second. Therefore, this is the 20 by 11 millisecond. So time interval between two successive compression is equal to 20 by 11 millisecond. Okay, understood? Next. The wavelength of a wave 0.35 meter of frequency 2000 Hz. We have to calculate the velocity of sound wave V. This is equal to nu into lambda. Okay, now we also have to calculate time to propagate sound wave 1500 meter. So look at this. First of all, we have to calculate the velocity of sound wave. Here V is equal to nu lambda. Nu is given, lambda also given. So this is the 2000 into 0.35. So look at this. This is the 700 meter per second. Now time required to propagate 500 meter with this speed. So time t equal to, look at this. This is the S by V. So this is the 1500 divided by 700. Cancel. So this is the 15 by 7. So this is the 2.1 second is the required time to take by sound wave to travel the 1500 meter. Okay. Understood? Now speed of sound wave. The speed of sound wave depends on elasticity and density of the medium. Okay? Density of the medium. Now the solid has more elasticity than liquid or gaseous medium. So velocity of sound wave in solid is most. Now elasticity of liquid is more than the elasticity of gaseous medium. That is why the velocity of sound is greater in liquid than air medium, and velocity of sound wave is least in air medium. Okay, next. Now we have to define two important terms relating to sound wave. First of all, intensity. Suppose sound wave propagates along this direction. So intensity is the rate of flow of energy per unit area placed normal to the direction of flow of the sound wave. So its unit is watt per meter square. Okay. Now intensity of sound wave depends on, look at this. First of all, intensity directly proportional to square of amplitude. So twice the amplitude, intensity becomes 4 times. Intensity depends on distance of the source from the observer. Intensity is inversely proportional to the square of distance of source from the observer. Therefore, I proportionate 1 by d square. So twice the distance, intensity becomes 1/4. Next, intensity depends on density of the medium. Greater the density of the medium, greater is the intensity of sound wave. Intensity also depends on velocity of sound wave, I proportionate V. Okay, greater the velocity, greater the intensity. Intensity also depends on motion of the medium. If the medium moves in the direction of propagation of sound wave, intensity more. And finally, intensity depends on presence of a resonance body. Due to presence of resonance body, intensity is more. Okay. Now loudness. Loudness is the auditory sensation produced by sound wave. It is not a measurable quantity. It is the perception. Now difference between intensity and loudness. Look at this. It is the rate of energy flow per unit area. It is auditory sensation. It is physical quantity. And its unit is watt per meter square. It has no such unit. It is the cause of loudness. It is the effect of now a reflection of sound wave. When a sound wave propagates from one medium to another medium. At the surface of separation of two medium, the part of the energy back to the first medium. This phenomenon is known as reflection of sound wave. Now look at this. This is known as the incident wave and this is the reflected wave. If this is the normal at the point of incidence, so this angle is equal to this angle. That is, angle of incidence is equal to angle of reflection. Okay? Now, laws of reflection of sound wave. Incident sound wave, reflected sound wave, and normal at the point of incidence lie on the same plane. And second law, angle of incidence is equal to angle of reflection. Okay? Understood? Now, difference between the reflection of sound wave and reflection of light wave. Look at this. As wavelength of sound wave is large, so large reflector is required for the reflection of sound wave. Okay? For light wave, small reflector is required. Okay? For reflection of sound wave, smooth reflector is not required. But reflection of light wave, very smooth reflector is required. Okay? Understood? Now most important phenomenon, echo. If reflected sound is heard separately from original sound, then reflected sound is called echo of the original sound. Now to calculate the minimum distance of hearing echo, we have to define the term persistence of hearing. A sound persists in our brain in 1/10 second. This is known as the persistence of hearing. So persistence of hearing of human being is 1/10 second. Now minimum distance of hearing echo. Suppose this is the source of sound. Now sound moves to the reflector and again reflected back here. If this distance is the d, look at this. If this distance is s, so look at this. This distance plus this distance is the 2s. So 2s distance travel by the sound wave in 1/10 second, that is in time t. So look at this, 2s, this plus this is equal to velocity into time. Okay, so minimum distance s is equal to half vt. At 22 degrees Celsius, the velocity of sound wave is 344 meter per second. And t, persistence of hearing, is 1/10 second. So if we put here, we can get s equals to, this is the half into 344 into 1/10. So look at this, this is the 17.2 meter. So minimum distance of hearing echo is 17.2 meter. Okay? Understood? Now example 12.2. A person clapped his hand near a cliff and hear its echo after 2 seconds. The speed of sound wave is 340 meter per second. We have to calculate the distance of cliff from the person. Now look at this, the distance of this, now look at this, this is the formula to calculate the distance of reflector from the observer. This is the s equal to half into v into t. V is the velocity of sound wave and t is the time of hearing echo. This is the s equals to half, v is the 346 and t is the 2. Now this and this cancel out. So s equals to 346 meter is the distance of cliff from the person. Okay. Now look at this, an echo is heard after 3 seconds. Velocity of sound wave is 342 meter per second. We have to calculate the distance of the reflector from the source. What is the formula? Formula is, look at this, this is the S equals to half V into T, where V is the velocity of sound and T is the time of hearing echo. So look at this here, S equals to, this is the half, V is the 342 and T is the 3 meter. Okay. Now look at this and this is the 17.1. This is the 513 meter. Okay. Therefore, distance of reflector from the source is 513 meter. Okay. Next. Now use of multiple reflection. Megaphone, horn and some instrument like Shanghai, trumpet sends sound wave in a particular direction. This instrument consists of a tube, and in this tube multiple reflection takes place and sound propagates in a given direction. Okay. Number 2. The speaking tube. Speaking tube is an instrument which sends sound wave in a particular direction by multiple reflection. Next, stethoscope. The instrument used by doctors to hear the heartbeat of a person sends sound wave in a particular direction by multiple reflection. Okay. Now audible range of sound. Human beings hear the sound of frequency from 20 Hz to 20 kilohertz is called audible range of sound. Now infrasonic sound. The sound of frequency less than 20 Hz is called infrasonic sound. Rhinoceros, elephant and whale can hear the infrasonic sound. It is observed that some animals get disturbed before earthquake because earthquake produce a infrasonic sound before main shock waves. Okay, the infrasonic produced by earthquake alert the animals which hear the infrasonic sound. Now ultrasonic sound. The sound of frequency more than 20 kHz is called ultrasonic sound. Bat, dolphin hear this ultrasonic sound. Now look at this numerical 7. The typical range of hearing sound is 20 Hz to 20 kHz. Velocity of sound wave is 344 meter per second. We have to calculate lambda minimum and lambda maximum. Look at this. We know V equals to, this is the new lambda. So lambda becomes maximum when frequency is minimum. So lambda max is the V by, this is the minimum frequency. So this is the 20. Now V is the 344 divided by 20. Therefore, this is the 17.2 meter is the maximum wavelength. Now we have to calculate lambda mean. So look at this here, lambda mean is V by 20 kilohertz. So V by 20,000. Look at this, this is the 344 divided by 20 into 00 meter. So look at this, this is the 17.2 into 10 to the power minus 3 meter. That is 17.2 millimeter is the minimum wavelength of our hearing range. Okay. Now application of ultrasound. First of all, cleaning. Ultrasound cleaning the places where hard to reach, such as spiral tube or shape part of a electronic components. Okay. Number 2, ultrasound detects crack and flaws in metal block. So it detects cracks and flaws in metal block. Echocardiography is done by ultrasound. So this is the echocardiography. Echocardiography is the image formation of different part of hearts with the help of ultrasound. Ultrasonography is also done by ultrasound. So this is the ultrasonography. Ultrasonography is the process of formation of image of our internal body part with the help of ultrasound. Ultrasound also used to break the small stone in kidneys, gallbladder, etc. So break the small stone. Okay, next, sonar. The full form of sonar is sound, navigation and ranging. It is an instrument which contains a transmitter and detector of sound wave. With the help of sonar, we can measure the depth of sea. Number 2, location of submarine. Okay. And location of an object in the sea. Now with the help of sonar, we can measure the depth of a sea. Suppose depth of a sea is D. A sonar produces sound from here. This sound moving towards the seabed, and after reflection at the seabed, the sound again reaches to the sonar. Now the sound reaches from this position to this position. The time interval between production and detection of sound wave in the sonar is small t. So in time t, the distance traveled by the sound wave, this is the d and again d. So look at this 2d, this is equal to v into t. Therefore from this equation, d is the half into vt is the depth of sea. So d equals to half vt is the depth of the sea. Okay, a sound wave produced by the sonar of a ship and reflected back by the seabed in 3.42 seconds. If the velocity of sound wave in water is 1531 meter per second, we have to calculate the depth of sea. Look at this, the depth of sea d equal to, this is the half vt. Here v given, t given. So we can easily calculate the depth of the sea. Look at this, here d equal to, this is the half, v is the, this is the 1531 and t is the, this is the 3.42. This is the meter. Okay. So look at this and this cancel out. So this is the 1.71. If we multiply this and this, we can get 2618 meter. So depth of sea level is depth of sea is 2.62 kilometer. Okay, understood? Next, now characteristics of sound wave. The characteristics of sound wave, first of all, intensity or loudness. Number 2, pitch. And number 3, quality. The intensity is the rate of energy flow per unit area placed normal to the direction of sound flow. It depends on amplitude, distance of the source from the observer, medium, density of the medium and motion of the medium, and finally presence of a resonance body. And pitch depends on frequency of sound wave. If the frequency of sound is more, then pitch is higher. If the frequency low, then pitch is low. And quality. Quality is the property of sound wave by which we distinguish two sound waves having same intensity and pitch. Okay, it depends on number of overtone present in a sound wave. Okay. Now numericals of Ncert. Look at this, frequency of sound wave is 100 Hz. We have to calculate number of vibration in 1 minute. Look at this, frequency of 100 Hz means number of vibration in 1 second is 100. So number of vibration in 1 minute, this is the 60 into nu. So this is the 60 into 100. So this is the 6000 is the so this is the 6000 is the number of vibration in 1 minute. Okay, look at this, numerical 13. A stone is dropped from a tower of height 500 meter in a pond at the base of the tower. Now we have to calculate the time of hearing the splash. Now time of hearing splash is equal to time taken by the stone to reach the pond and sound produced, and this sound reaches here. So look at this, the time of fall of stone T1 is equal to 2h by g, and time taken by sound to reach from this position to this position is h by v. So we have to calculate this. Now here h given, g given and v given. So look at this, t is equal to root under of 2 into 500 divided by g means 10 plus this is the 500 divided by 340. 0 cancel out. Okay, so look at this, this cancel out. So this is the 100, so this is the 10, and look at this is the almost 1.5. So time taken is 11.5 second. Okay, understood? So time taken to hear the splash of sound is 11.5 second. Okay, understood? Look at this, the velocity of sound wave is 339 meter per second and its wavelength is 1.5 centimeter, that is 1.5 into 10 to the power minus 2 meter. We have to calculate the frequency. Now we have to also calculate, will the sound be audible? Look at this, here nu is equal to, this is the v by lambda, v is the 339 divided by 1.5 into 10 to the power minus 2. So this is the 33900 divided by 1.5. This is the 2266 Hz. So look at this is the more than 20 kilohertz. So this sound is not audible. Okay, look at this, a sonar in submarine sends sound wave and reflected sound is detected after 5 seconds. If the distance of the object is 3625 meter, we have to calculate the velocity of sound in water. Look at this, we know the minimum distance of the reflector is equal to half v into t. V is the velocity of sound in water and T is the time interval between production sound and detection of sound. So look at this, here 2D equal to Vt, so V equal to 2D by T. Now put the here now, so V equal to, this is the 2 into 3625 divided by, this is the 5. Okay, now look at this equal to, this is the 725. Okay, therefore the velocity of sound wave, this is the 1450 meter per second. Okay, understood? Many thanks for watching this video. This video will be extremely beneficial for your examination. Please like, share and comment on this. And if you are new, don't forget to subscribe to get the new concepts in physics. Okay.